A 15-inch laptop has a screen that is 7 inches tall. How wide is the screen? We're asked to give the answer to 2 decimal places, and we're also reminded that laptop computers are measured according to the diagonals of their screens. So because we have a 15-inch laptop, the length of the diagonal of the screen, this length here, is 15 inches. The screen is 7 inches tall, so the length of this side here would be 7 inches. We're asked to determine how wide the screen is, which should be this length here. This length is unknown. But notice how these three sides form a right triangle. And because we know the lengths of 2 of the 3 sides of the right triangle, we can use the Pythagorean theorem to determine the length of the missing side. The Pythagorean theorem is given as a squared plus b squared equals c squared, or c squared equals a squared plus b squared, where c is the length of the hypotenuse, which is this side here. This is always the longest side. It's also the side that is always opposite the right angle. The other 2 sides are called the legs. The lengths of the legs are labeled a and b. The legs are the 2 sides that form the right angle. It doesn't matter which leg we label a and which leg we label b, because notice how in the equation a squared plus b squared is on the same side of the equal sign. So looking back at our right triangle, notice how the hypotenuse is a length of 15 inches, and therefore c is equal to 15. One leg has a length of 7 inches, the other leg has an unknown length. So let's go ahead and label the unknown length a for a inches, and let's let b be this leg, and therefore b is equal to 7, or 7 inches. And now let's use the Pythagorean theorem in the form a squared plus b squared equals c squared. So we'll substitute 15 for c and 7 for b. So we'd have a squared plus 7 squared equals 15 squared. So we have a squared plus 7 squared is 49 equals 15 squared equals 225. Next step is to isolate a squared. So we subtract 49 on both sides. Simplifying, we have a squared equals 225 minus 49 is equal to 176. To undo the squaring and solve for a, we'll take the square root of both sides of the equation. Solving algebraically, we'd have 2 solutions for a positive and negative value. But for this application problem, because a is a length, we know a is positive. So we'll take the principal square root of both sides of the equation. The square root of a squared equals a. So a equals the square root of 176. Let's first get our decimal approximation, which is what the question asks for, and then we'll give the exact length as a simplified square root. So going to the calculator, second x squared brings up the square root, 176, enter. To 2 decimal places, a is approximately 13.27 inches. So this is what this question asks for. Let's also show how to simplify the square root of 176 to give the exact value of a. The square root of 176 will simplify if 176 has any perfect square factors. To help simplify this, let's look at the prime factorization of 176. 176 is equal to 2 times 88. 2 is prime. 88 is equal to 8 times 11. 11 is prime. 8 is equal to 4 times 2. 2 is prime. And 4 is equal to 2 times 2. So a is equal to the square root of 4 factors of 2 and a factor of 11. Well, 2 times 2 is a perfect square here as well as here. So this part will simplify, and we'll still have 11 under the square root. So a is equal to, well, the square root of 2 squared, or 2 times 2, equals 1 factor of 2 here as well as here. So we have 2 times 2 outside the square root times the square root of 11, which equals 4 square root of 11. Of course, this is still inches. So here's the value of a rounded to 2 decimal places, and here's the value of a as a simplified square root. I hope you found this helpful.